Welcome to Brain Vision.
To begin the problem, we are going to first recall definition 7. So the definition 7 says f is differentiable at x comma y if I can write the increment of f delta z as delta f delta x times delta times x plus, then let me erase that, delta f delta y times delta of y plus delta of x times epsilon 1 plus delta of y times epsilon 2, where what is my delta z? Delta z is equal to f of x plus delta x, comma, y plus delta y minus f of x comma y. So this is the increment of f with respect to x and y, so we call it by delta z. And of course I know the delta f delta x are the partial of f with respect to x and partial of f with respect to y respectively, and we have the condition on epsilon 1 and epsilon 2. What is that? Epsilon 1 and epsilon 2 goes to 0 as delta x delta y goes to 0. Okay, so we are going to use this definition to verify the differentiability of the function. So let's write down the function. F of x comma y is equal to xy minus 5y square. So then what is my delta z? Is equal to f of x plus delta x comma y plus delta y minus f of x comma y. So what is this? X plus delta x. We can put a parenthesis, it really doesn't matter. The book doesn't use the parenthesis, so it's fine. So x plus delta x times y plus delta y minus 5 y plus delta y whole square minus, what is f of x comma y? So minus x times y, and 2 minus makes it positive 5y square. So let's evaluate this. So this becomes x times y plus x times delta of y plus y times delta of x plus delta x times delta y, and then negative 5y square, and then negative 5 delta y whole square, and then so this will give me plus 2ab, like, so minus 10 y times delta of y, and then I also have xy plus 5y square. So xy and xy cancels, 5y square, this 5y square cancels as well. So now I have this term x times delta of y plus y times delta of x plus delta x times delta of y minus 5 times delta of y whole square, and then negative 10 y times delta of y. Okay, so next we are going to evaluate our delta f delta x at x comma y. So what is that? So the delta of delta x of xy minus 5y square, which is going to be y minus 0, so y, and similarly delta f delta y at x comma y is going to be, so x minus 10 times y. So this implies delta f delta x times x comma y times delta x is going to be y times delta x, and delta f delta y times x comma y times delta of y is going to be x times delta y minus 10y times delta y. So if I just go back to the expression, so I can combine this term and this term, and as well as this term and this term. Sorry, so we cannot combine this term. So I will just write that down. So this 3 underlined term into delta f delta x times x, then del f del y times delta of y. So let me just write that down. So I end up getting delta z is equal to delta f delta x comma y times delta times x plus delta f delta y times delta of y. And let's go back, let's see what are the expression we still left with. So we have this extra term, so delta x delta y minus 5 delta y whole square. So these are the only two excess term, so I will just write that down. So delta x delta y minus 5 delta y square. So what is our choice of epsilon? So we can take epsilon 1 is equal to our delta of y, and epsilon 2 is equal to negative 5 of delta of y. Why? So then I can see that delta x times delta y can be written as epsilon 1 times delta of x, so delta of x, and negative 5 delta y whole square can be written as epsilon 2 times delta of y, and epsilon 1 and epsilon 2 goes to 0 as delta x delta y goes to 0. So QE